electronic configuration of titanium. Positive 2, titanium ion, positive 2. And what is given for us that the titanium is here, what is given is titanium is 22 and the argon is what? Is 18. Okay, to find the electronic configuration of the ion, as we explained for the previous questions, we need first to find the electronic configuration of the natural atom, of the atom itself, where it has 22 electrons. Then after that, 2 electrons will be lost of this one. Here now, to find the titanium 22, how it's going to be organized. Here the argon is 18, and we need that this here, what is given here is based on the noble gases notations. So that means noble gas notations, as we know, it starts by helium, then neon, then argon, then krypton. So no need to use it here. So this one by, and we know each one it takes how many electrons. So helium it takes 2 electrons, and we said that, and here this one is 10 electrons, and here it will take what? 18 electrons, and we need to memorize that. So an argon takes 18 electrons. Good. What comes after 18? That means we're going to use 18 electrons of the titanium 22. So that means we're going to use argon now. And when we mention argon, that means the third period has been finished. The third period has been what? Has been finished. Good. So when we use argon, third period has been finished. Okay, now when we write just here, when we mention argon, that means we finished or we completed the third period. What comes after the third period? In the periodic table, the fourth period. And the fourth period, it starts by 4s, where it takes 2 electrons. Okay, how many electrons now are used? Here now, as we see, here 18 electrons are used, and here is 2, so 20 electrons are used. Where, how many electrons we have in the titanium atom? We have 22. So that means what comes after 4s? We know that it comes as 3d, and 3d takes what? 2 electrons. 3d takes what? 2 electrons. So this is now the atom of titanium, which is 22 electrons, how they are organized. So they are organized in electronic configuration exactly this way, that is here. Okay, good. But the question now is not about the atom. The question now is about the ion, which is positive 2. And positive 2 here, it means number of protons are more than electrons by 2. So that means it means when it is positive 2, that means this atom lost 2 electrons. Good. When this atom here, that is here, when it loses 2 electrons, will it lose the 2 electrons from here, from this part, or from this part, or from this part? It will lose, and any element, when it loses electrons, it loses the electrons from the higher energy level. And the higher energy level is represented by the number which is the coefficient of the sub-levels. So here is 4s, and here is 3d. So which one is higher energy level? It's 4s here. So that means when it loses electrons, it will lose them from the 4s, and it will lose 2 electrons. So what will be left then? Only argon, which is 18, and 3d with 2 electrons. So that means you're going to find this is the answer. And we said that when we fill the electrons, we fill them by the increase of energy level. So 4s comes before when we're filling the electrons. 4s is less energy level than 3d. But after they get filled by electrons, the opposite will happen. 3d will become less energy level because the attraction towards the nucleus of the d will be higher. So that means 4s then, after filling the electrons, will be higher energy level, and here it's going to be the one that electrons will be lost from. And just take it as a rule, when electrons are lost for any element, it is lost from the higher energy level that is represented by the number which is the coefficient of the s or d or f. The higher number there, it will be lost. So in this case, B, as we said, will be the answer.